What's up everyone, welcome back. Patrick here, moving on to the next example in advanced functions, another question where we are given the characteristics of a function and we have to make a graph that is going to match those characteristics. And so this one is going to be a little bit tough, more so tougher to explain, but hopefully you or I'll try to do as best of a job so you could follow along. Now, remember what I've mentioned before with these kinds of examples? I always like to start with concrete characteristics. So characteristics that there's not going to be any subjectivity involved. And so that starts off with actual coordinates on the function. And notice that this characteristic gives us actual coordinates. So notice the x-intercepts are -3, 0, and +3. So if we plot those, we know that the function for sure has to go through those points right there. So I always like to start off with those. And then these other characteristics, there is a little bit more subjectivity involved, and so we have a little bit more flexibility with how we are going to plot it. We just got to make sure that it's going through these points. Now, first characteristic here I want to talk about, f of x is odd. Now, if you remember, when a function has odd symmetry, what that means is that if we take 1/2 of the function and reflect it in both axes, in both the x-axis and the y-axis, we're going to end up with the second half of the function. If it has even symmetry, then we only have to reflect it over the y-axis, right? 1/2 over the y-axis to get the second half. But when it's odd, we got to reflect it in both axes. So we got to make sure that our sketch is going to satisfy that. Second characteristic, f of x is continuous. That's fairly self-explanatory. It just means there's not going to be any break over the domain of this function. So no like holes or vertical asymptotes or anything like that. And then over here, we're told that the function is increasing on these two intervals between -∞ and -2, and then from 2 to +∞. And remember, these intervals are always written in terms of the x values, right? So we know from an x value of -∞ to -2, and then from 2 to +∞, function has to be increasing, meaning the y values are going up as we read from left to right. And then it's going to be decreasing between x values of -2 and +2. So I'm actually just going to plot those x values because we're going to be using those as well. Plot them there. So what else do we have to do here? Now, actually, one thing I want to mention too, another way that these intervals could be written, this is an interval notation. It could also be maybe written in set notation. So you could have x is less than -2, x is greater than 2, right? So you might see questions describing intervals like that. Both of those mean the same thing. Okay, so let's try to draw something here. Now, we know that the function is going to be increasing to -2, but then it's going to be decreasing after -2, between -2 and +2. So we know that basically at -2, there's going to be some kind of local maximum value, because up until that point, the function has to be increasing, and then after, the function is going to be decreasing. And then notice that at +2, it's going to be the opposite. It's going to be decreasing up until +2, right? Decreasing up until +2. And then after +2 to infinity, it's going to be increasing. So we know that at +2, at an x value of +2, there's going to be a local minimum. Yo, what's up? Quick little intermission here. I wanted to mention a few things and we'll get right back into the video. Number one, if you're watching this on YouTube, you can go to the description box and there's a link that will take you to my website, allthingsmathematics.com, and there you can find all of the videos organized by chapter, by section, and there's also tests that you could try at the end of each unit that have video solutions. Number two, if you feel like you need tutoring at any point, hit me up. I'm tutoring students 7 days a week over Zoom, both high school and university students, one-on-one and in groups. My contact details are on the website. You could text me and we could book a session. And finally, if you feel like you're getting any value from this video, if you could please like the video and subscribe to the channel, hit me up on all my socials. It does help me out a lot. If you feel like any of your friends can benefit, feel free to forward the website to them as well. And back to the video we go. Now, one thing you got to be careful with these 2 points when you plot them is that they have to have the same y value, because remember, f of x has to be odd. That characteristic has to be met. And so if we put this point, let's say at an x value -2, and let's say, I don't know, a y value of 5. Well, then this point has to be at a y value of -5. Because remember, we have to be able to take this half of the function, reflect it in both axes, and get the other half. So this point, if we would reflect it over the x-axis, it would go to +5. Reflect over the y-axis, it goes to, from an x value of +2 to -2. Or if we take this point, reflect it, right, in the x-axis, it goes to this point, -2, -5. Reflect it in the y-axis, it goes to this point, 2 and -5. So these 2 points have to have the same y value, right? So this could be any y value. We could have it down here, maybe at +1, -1, up here, +10, -10, whatever, as long as these y values here are plus and minus. And so from here, we could just pretty much draw this, right? So let's maybe draw it in a different color. So I'm going to draw it up until this point. Then what's going to happen is it's going to come down like this. I'll just draw it as a straight line. Make life a little bit easier. So you know what? I'm going to draw this as a straight line as well to make it have that point symmetry. So if we draw that as a straight line, I'm going to draw that as a straight line down. Again, you can make it more curved if you want to, kind of like a polynomial function. But I'm just going to make it like that. And that right there, that function, that sketch, satisfies all the characteristics, right? So it is odd because if we took this half, reflected it over the x-axis, we'd end up with something like that. And then if we reflected that over the y-axis, we'd end up with this second half of the function. So that's met. F of x is continuous, right? There's no break in the domain. X-intercepts -3, 0, +3. It's increasing from an x value of -infinity to -2, right? It's increasing on this interval. The y values are going up as we read from left to right. From -2 to +2, function is decreasing, meaning the y values are going down as we read from left to right. And then from 2 to infinity, function is increasing, y values are rising as we read from left to right. And so that is an example of a sketch that matches these characteristics. And that is the end of the video. Hopefully you enjoyed that. If you want to find more videos like this, you can go to my website, allthingsmathematics.com. Over there, all my courses are organized for both high school and university. All the videos are organized by chapter. Also, if you have any questions, you can hit me up. My contact details are also on the website. Enjoy your day, and I'll catch you in the next one. Peace out.